In this video, I'm going to discuss sequence diagrams. The owner of the slides I use here is Dr. Timothy Lethbridge at the University of Ottawa. First of all, I thank him for granting me the permission to use his slides. Then let's begin. Before we discuss about sequence diagrams, let's talk about interaction diagrams. Interaction diagrams are used to model the dynamic aspects of a software system. Now, we have already discussed class diagrams. We have already discussed class diagrams. Now, using a class diagram, we can design the structure, the static structure of an information system or a software system. Now, let's say for an example, let's consider an information system for a university. Then from a part of the class diagram, we draw an example object diagram. That means student object is there, one particular student object. Okay, then we have many course sections. So course section, an object from course section is there. Then let's think one particular student needs to register for a particular course section. Then we need to create an object from registration class, registration object. Now there are three objects. Using the class diagram and as well as object diagrams, then we can design the static structure. But still, we do not have a way to model dynamic aspects, dynamic behavior of our information system. That means when a student registers for a particular course section, methods in these objects are executed. Okay, so that is a dynamic behavior of our software system. Okay, so actually we need interaction diagrams to model the dynamic aspects of software systems. Then they help to visualize how the system runs. Okay, then using interaction diagrams, we can visualize how a particular system runs. Then an interaction diagram is often built from a use case and a class diagram. Now I have already discussed use case diagrams. Then I hope you are familiar with what is a use case. Okay, so this kind of a symbol, no? This kind of a symbol we use to graphically represent the use case. Then register for an example. According to this example, register for a course, register for a course section. Register for a course section. Now, a student is the actor. So, in this way, stick person symbol is used for the actor, student. In this way, we can draw a use case. Okay, student is the actor performing this use case. Then we need a use case, and usually we need a use case and a class diagram in order to build an interaction diagram. Okay, so the objective is to show how a set of objects accomplish the required interactions with an actor. Then when actor performs a particular use case, then how these objects interacts with each other, okay, to perform this task. If you can remember the use case diagrams lesson I have taught, okay, so then you know use case is a typical sequence of actions to complete a given task. Okay, so in order to complete this particular task, these objects should interact with each other. So this interaction we model using an interaction diagram. Okay, so now let's move to the next slide. Interactions and messages. Interaction diagrams show how a set of actors and objects communicate with each other to perform. Okay, then set of objects and set of actors to perform the steps of a use case. Okay, that is one particular thing that can be modeled using interaction diagrams. Then that is the thing we focus in this course. Okay, how to model steps of a use case using interaction diagrams. In addition to that, the steps of some other piece of functionality, any other piece of functionality. If you have any other piece of functionality in stepwise, for them also we can use interaction diagrams in order to model. The set of steps taken together is called an interaction. In use case diagrams, now a use case, this is a use case. When it comes to interaction diagrams, we call this as an interaction. Okay, interaction. Instead of the term use case, here we use the term interaction. Okay, we use the term interaction. Interaction diagrams can show several different types of communication. We can show using interaction diagrams. One thing is method calls, and also messages sent over the network. In this course, we worry only about method calls. Method calls means, now if you consider this particular example, now you know that the set of methods are available in student class. Set of methods are available in registration class. Set of methods are available in course section class. So in order to complete this use case, we need to execute the methods available in these classes with respect to these objects. Okay, so now the communication happens. One thing is we should know the order of these methods getting executed. That is one particular thing. Okay, that is one particular important thing modeled using interaction diagrams. Okay, so even though they are method calls in interaction diagrams, we refer method calls as also messages. Okay, let's move to the next slide. Then let's discuss elements found in interaction diagrams. Instances of classes. That means instances of classes means, in other words, objects shown as boxes with the class identifier and object identifier underlined. This is an example. S1 student, we underline, then enclose it in a box. Now the other thing, class. Student is the class. Here we have to include, this is a colon, here we have to include object identifier, a label to identify the object. Okay, we refer our object, this is our S1 object. Okay, likewise student objects, we can create one S1 object, S2 object, S3 object. Likewise objects we can create using student class. Okay, this is an identifier to identify this particular object. So we graphically represent this object like this. Then since we have the underline, we can identify it is an object, and it is an object or an instance of this particular class, and identifier is this one. Okay, in that way we can represent objects in interaction diagrams. Now actors use the stick person symbol as in use case diagrams. In stick person symbol means this one. You are already familiar with this. When we were discussing use case diagrams, I have used this. Then this is an example, student actor. Okay, student actor. Now the other thing is messages shown as arrows from actor to object or from object to object. One thing is actor and object, then between an actor and an object, and also between two objects we pass messages. Okay, for this lesson simply think method calls. Okay, so we use arrows. Now arrows are used now in UML. When we use interaction diagrams, there are different types of arrows, but in this lesson I'm not going to discuss sequence diagrams in detail. Okay, we have discussed use case diagrams in detail, class diagrams in detail, but we are not going to discuss sequence diagrams in detail. And also in the next video I will discuss activity diagrams. Okay, uh, in that way, four diagrams will be discussed in this course. Okay, if you want to model a small scale information system or a software system, then these are the four essential, most important diagrams. Okay, one thing is use case diagram. Second one is class diagram. This is very important because class diagram, using the class diagram, we model the entire structure of our software system. This is very important. What we did using use case diagrams? Actually, we using use case diagrams, the one of the important thing we could do is to assist when we gather requirements. Okay, rather than writing requirements in piece of papers, using use case diagrams we can easily document our requirements, and we can analyze them. Okay, in that way, then furthermore, using use case diagrams we can model the communication between actors and the system. Okay, our system has interfaces, simply say graphical user interfaces, then actors or stakeholders, they communicate with the system through the user interfaces. Okay, then this communication can be modeled using use case diagrams. Now, as the third topic in this video, I am going to discuss sequence diagrams. Actually, sequence diagrams is one particular type of interaction diagrams. Okay, there are two types of interaction diagrams. Later I will mention the two. One of them is the sequence diagram. Okay, so these two topics I have discussed in detail, but sequence diagram and then in next video activity diagram, these two diagrams will be discussed in brief. Okay, so that is why there are different types of arrows used in sequence diagrams. We are not going to discuss the differences in the arrays. Okay, sorry, arrows. Okay, then let's move to the next slide. Creating interaction diagrams. You should develop a class diagram and a use case model before starting to create an interaction diagram. Now, you need the class. When we design your software system, first requirements, you have to gather requirements, analyze them, and likewise those things. In order to do those things, definitely you need not definitely, it's better if you use a use case diagram. Then you have to it's better if you can draw a class diagram in order to design the static structure of your software system. Then you need both of these diagrams, okay, in order to create an interaction diagram. Okay, interaction diagram. Now, in order to yes, there are two types of interaction diagrams, two kinds of interaction diagrams, sequence diagrams and communication diagrams. Okay, so in this video we only discuss sequence diagrams. Okay, this is what we discuss in this video. Now this is an example. This is an example for a sequence diagram. Now you can see this is an actor. So we have three objects: course section, registration, and student. This is the example I have already mentioned. And now you know that if you consider the part of the class diagram, not the entire class diagram, okay, the part that is relevant to registration of a student to a particular course section, okay, only that part we focus, not the entire class diagram. Okay, for that part now we have a use case, no, register for a register for a course section. Now we have a use case. When it comes to interaction diagrams, use case is an interaction. So in order to perform this particular interaction or the use case, now three objects are there, no? Course section, then registration, a student. Now we know that there are methods available in course section class, methods available in registration class, and also methods available in student class. Then if you look at the class diagram here, we have in this particular, we have two methods in course section class: request to register, okay, request to register. That is a one particular method. So actually here I have in these slides the parameter lists are not shown and return types are not shown. Okay, just to simplify the discussion. Okay, but actually these methods should contain return types, parameter lists, and so on. Okay, here I simply use the name request to register, then add to registration list, add to two methods are there. So by the name you simply get an idea. Request to register, that means the body of this method should be performing some actions to handle the request. Then add to registration list of registered students, something like that. To that list we have to add. Okay, so in that way you get some idea. Then Add to schedule. In student class, add to schedule. That is one particular method. Then those are the three, not the only method, all the methods available, but those are the three methods available in this and this class. Then actually now using the sequence diagram, what we do is then first you have to, in the sequence diagram, this is how time goes. Okay, therefore very first thing, we invoke request to register method available in course section object. Okay, with respect to this course section object, we invoke request to register method. Therefore this is the first one that is executed. Then once we have executed the request to register method, then the meaning of this one, actually these are two different types of arrows, but simply forget it, okay, because we do not discuss sequence diagrams in detail in this course. Now anyway, here create means an object from registration class is created for the second time, as the second step. Okay, so here create, actually in order to create, what should we do? We have to invoke the constructor of registration class. Now this is the second step. Second execution. Then after that, add to schedule, that is available in student class as the third step. This is executed. Then after that, add to registration list method is executed. So this is the fourth one. Now what we should understand here. Now the name of this diagram is sequence diagram. Sequence diagram means now it defines the sequence of execution of methods. Okay, so that is the idea of sequence diagram. Now from the arrowhead, we can identify now this method is available in course section class. Here this method is available in course section class. This method is available in student class, where we have the arrowhead. That method is inside that particular class corresponding to that particular object. Okay, so that's what you should understand. Then let's discuss the elements in sequence diagram. A sequence diagram shows the sequence of messages exchanged by the set of objects performing a certain task. Objects are arranged horizontally across the diagram. Okay, now you know horizontally objects are arranged. An actor that initiates the interaction is often shown on the left. This is the actor who initiates the interaction. Actually, in this context, this is a student. Okay. The vertical dimension represents time. In this direction, we represent time. That means at the beginning, request to register, then create, then add to schedule, then add to registration list. Okay. Likewise, time flows in this direction. This is our time axis. Okay. Now, vertical line called lifeline is attached to each object or actor. This kind of this is called lifeline. Okay. Then the lifeline becomes a broad box called an activation box during the live activation period. We have a box. This is called activation box. This is called lifeline. This one is called activation box. Actually, activation box symbolizes the live activation period of the object. So within this period, within this period, messages are exchanged between objects. Okay, within their live activation periods. A message is represented as an arrow between activation boxes of the sender and receiver. Then sender and receiver are there. If a message is exchanged, it should be performed within activation boxes of the two objects. Okay. Or actor and object. Anyway, because these boxes symbolizes the live activation period. Okay. A message is labeled and can have an argument list and a return value. Here, these are the messages. Actually, in this situation, these are methods. Therefore, for a method, there is a return type and also there is a parameter list. Understood? These two things are there. No? So here, actually, we have to mention return type along with the parameter list. So, but simplicity, for the sake of making you understand easily, I have just used name of the method to label these messages. Okay. So now that's not all about sequence diagrams, but in this course we discuss this is the only content we discuss about sequence diagrams. Now you have actually learned use case diagrams. Then you learned in detail about class diagrams. In this video now, you have gathered knowledge about sequence diagrams. In the next video, you will learn activity diagrams. Okay. Now, if you want to design a small scale software system, these 4 diagrams are enough. Okay, that is why in this course I selected these 4 diagrams. Actually, these are the essential diagrams for okay, on my opinion. Okay, these are the 4 essential diagrams for a small scale software system. And using use case diagrams, we could gather requirements. We can gather requirements properly, then analyze them, and also I understand the communication between between the actors and the system through user interfaces. Okay, that is done by use case diagrams. Then your software system, your information system, okay, we have to design its structure. Just like when you build a house, you have to decide the structure: bedrooms, kitchen, living area, car porch. Likewise, you have to design the structure. In the same way, class diagrams are used to design the structure. Once you have designed the structure, then you can use object diagrams to illustrate, to explain more about class diagrams. You can use object diagrams. No, now you know how to design the static structure of an information system, but dynamic aspect or the dynamic behavior, just like what I have just discussed, steps of a use case. How can we model that dynamic behavior? That can be done using sequence diagrams. And in addition to that, I decided to discuss about activity diagrams, because let's say if you press the register button, then in your software system, register button, register for a course section. Okay, then internal behavior is occurring. Okay, later you will understand. Anyway, when you watch the video relevant to activity diagrams, you will understand that activity diagrams are used to model the internal behavior of your software system. Okay, so in this way, this is this thing you should know at the end of this video lesson. Okay, now this is the end of this video lesson, and thank you for watching.